Thank you. Good afternoon. How are you doing? You survived to the last session of our conference. Yeah, it's always a great experience to have a last session of the conference just after the lunch. So I'm lucky. So my name is Dmitry. I'm MVP in business applications. I have about 15 years of experience in NAV, but also I have an experience in AI for about 3 years. So I have like a mixed, something mixed in my brain. So I live in St. Petersburg, have 2 kids. So today we will speak about, well, it's artificial intelligence and but it's more marketing world. We will dive into this word. We will look into the machine learning process, and then we will dive into Business Central frameworks that allow you to deal with machine learning areas. Yeah. So, by the way, who was in my session about artificial intelligence last year? Okay. So yeah, last year I was focused more like how to build models from scratch. So I will not focus on this year. I will focus how to consume ready models, but also point you to the some examples how to build models from scratch if you want. So. But before we start, I just ask you to take a selfie and send it to this mail. You can use QR code to access your email. I will not do anything with your selfies and with your emails. I will drop it just after the session. I will do this selfie by myself as well. Myself and doing your selfies. So, yeah, done? Okay. So, for example, well, every task. Well, I think most of you are developers, or if you are even consultants or managers, your job is to solve some tasks, yeah, right? And you need to know what you are going to solve. So, for example, your customer manager or maybe wife ask you to solve some case, like how many items I will sell next week, or maybe your wife asks you how much of them can I buy, and what you normally do in these situations. Well, in the past, in 92% cases of today, you start conversation. So, what influence on this task? So. If you want to sell something and you sell that before, and you want to know how much will you sell in the future, so actually you will do some conversations and ask questions. So what influence on your sales? And then there is some this brainstorm phase when you can just think about what's influence on your sales. Then I think it's not the correct slide, not maybe with your wife, but yeah. Then you end up with final solution, and your final solution usually is an algorithm. So, algorithm. What is algorithm? It's a combination of if-else, right? So, if some item, if it's a weekday or Saturday, maybe like this. If there is some event near your place where you sell your items, and many ifs, then your forecast will be like some value. Then combinations of else and somewhere. So it's an algorithm. That's actually what we call classical development approach. So we start with some question, what we are going to solve. Then we define this algorithm. Then we actually code that. Then we test that. Then we release that. Well, then we cycle that. Throwing this away. So do we have an alternative to that? Yes. And the answer is data. So think about the situation when somebody or something just looking at your data can produce these algorithms for you. Like that will be at the bottom also a combinations of many if and else, but you don't care how. You just have a data. So for example, you have some item ledger entries or any kind sort of data in your Business Central, and there you have actually two groups of columns. The first group of columns called features. So what are features? Features actually are something that influence on your future predictions. In this case, something which influence on sales, if you want to predict sales. In the other group, actually it's usually one column. It's something that we want to predict, and it's called a label. So with the machine learning process, usually you will see these two terms, features and label. So features what influence on features, something which influence on labels. Then you have this, you just apply some magic, let's call it like that on current phase, which is called machine learning. So machine learning actually it's a collection of mathematical algorithms, which are not something new, which were created like even in the previous century. And then you have a predictive model. So predictive model is some kind of black box, or in a machine learning world it's called a learning function, that knows how to get labels from features. Okay? So this is actually a collection of this if-else on the bottom. Okay, now we have a model. Okay, and you want to predict future. You need to tell this model what will be the features in the future. For example, you want to predict, well, in our case, sales, and maybe currency exchange rate or weather are our features, and they influence on our sales. If you trained, well, I will explain what is train a model further, but if you created this model using these features, that means that to make a predictions, you should know what will be the weather, what will be the exchange rates in the future. So many people actually think that machine learning is some kind of black box, and you have many different unsorted data, and you just push this data in this black box, and then you can just ask everything. Well, it's not like that. On those features which you used for creation of model, these features you should use only to get predictions in the future. So, yeah, actually without any development in our case, because we will use Business Central framework for that. Well, almost without any development. And now, when you have this trained model, this model actually is done with the artificial intelligence, but yeah, artificial intelligence is more like a marketing word. Actually, it's done by machine learning. So, two terms, artificial intelligence and machine learning. Do you know the difference between them? Yeah, okay, so. So, artificial intelligence or AI actually it's not a technology, it's tasks that are characteristics of human intelligence, like vision, speech, language understanding, maybe some predictions and so on. So it's some kind of tasks, so very complicated tasks that very easy to solve for us as a humans, but very difficult to develop in the software. Machine learning, in this case, it's a way of achieving these tasks. So these machine learning are the techniques, the algorithms, or the process, so the tools that allow to create these if-else models on the bottom from the data. So that's mostly statistical algorithms used inside. But I think, well, if artificial intelligence only tasks and machine learning are the tools, can we solve artificial intelligence tasks with a classical development approach? Well, technically yes, because if you remember, maybe in the beginning of 19th, there were some OCR companies that tried to recognize handwritten text using the classical development approach. They invested millions of dollars in the millions lines of codes, and the quality was poor, right? But still, you can have this as an option. There is something in the middle, actually, where you can use as a hybrid. So, for example, which means that if you have some complicated task, it's not always could be solved by only machine learning process. You can divide this task into subtasks. Part of them solve with a machine learning, part of them with a classical development, and then combine them to get their final result. That will be a hybrid. So, one more important to understand from that in machine learning process, computers learn from the data. Why AI became so popular today? Because mathematical algorithms, they existed before. That's because of now we have too much data. We can just apply it. Now we can apply these mathematical algorithms to this data, and we have resources to calculate them. So some statistics, for example, before 2003, all the humanity together produced 2 exabytes of data, like from the beginning of humanity. Then in 2013, we produced 10 exabytes of data. In 2019, we produced 715. So actually now we produce about 2 exabytes of data every day. So that's, wow, right? So where AI can be applied? Well, actually in any kind of industries. Like a food industry, you can check the quality of the products. You can forecast yield of the food and in cooking and so on. In the production, for example, I had a real case actually, which works, but I don't think if it's legal in Belgium. but it's legal in most of the countries, like Netherlands, US, some states in the US. So let's call it plants. So there was a manufacturing process of growing plants, and actually we used their custom vision model. We trained custom vision model to analyze the phase of growing of this plant, and we connected that to the IoT, some IoT devices, where it actually analyzed if the current phase of the plant is normal or less, or it should grow quicker, and then it sent a comments to increase lights, for example, and to increase temperature, and so on. So that was interesting experience. Unfortunately, I didn't have enough test samples for that, but yeah, just some remote work. So everywhere we can apply artificial intelligence with some knowledge of how to apply and with some creativity. So let's move into the Business Central. We have in Business Central predefined frameworks to train machine learning models, actually. So here are the APIs. So that's not like an official split of these frameworks, but I split it on this way, because every framework here solves some special type of tasks. So now we will go through each of these frameworks, see them in action, how you can develop smart applications using these frameworks. Microsoft also use these frameworks in some of their extensions that comes with Business Central as well, like a time series. That's the oldest one, actually. So it appeared in, I guess, NAV 2017, maybe in 18. So inventory sales forecast and cash flow forecast, they consume this framework. Then ML prediction, it's another type of a framework. Late payment prediction extension use this framework to get predictions. Then custom Azure ML, it's built for custom models created in Azure Machine Learning Studio. That's something that I showed last year. Then a custom vision, it's an image analyzer tool. So to train, actually, well, not to train, but to get predictions about what's inside of the image, what's text, and so on. So let's look in the time series API. Where you can apply this one. You have data in Business Central, and what's important part, this data should have a date field, which will answer on the question when happened. It should have some master data reference, like what. For example, item number if you want to get the forecast for items, or customer number if you want to get information about some customers, and so on. And, well, how much? It could be quantity, amount, or whatever, but it should be some decimal or integer value. Then you take the pre-built model already pre-built for you. You just copy that to your Azure resources and publish as a web service. And then you call this web service from Business Central using this time series API, which is stored in code unit 2000. So let's see the demo for that. I will show first the process, then I will dive you into the code, how it works. So assume we have here some, yeah, you see the screen. So assume you have here like a item ledger entry, but this is actually my custom table about the sales of my items with some additional fields. So that's, well, in current phase, you should just know that this is a completely custom table, so it could be any table in a Business Central, actually. We go to the items. Of course, it's start to be a little bit slow. So we go to the item card. And here on the item card, I have my own action which I created, which is called update forecast for this item. What he's doing now, he gets all the historical data about this item, sends it to my published web service to get predictions, and return me the predictions about sales for this particular item for the next 7 days. And you see that we have some values here, but they are the same for every day. I will describe why a little bit later. Let's go to the code first. So, where is my, I guess it was my page extension. Calculate forecast. So, how this framework, how you can use this framework? First, there is a variable. Do you see okay, or should I zoom it? So the code unit calls time series management. That's the first variable. The second is my custom table, or it could be some base table in a Business Central. And then, well, date. That's I just use date record to loop and to make calls to take a forecast for each date. Then I use two buffer tables. Describe it in a moment, and then time series model. Also describe that in a moment how it works. So the first step here, I'm connecting to my web service. You see that here is an initialize function with a URI and a key. So how to get this web service? There is actually one, well, during this session you will see two secret links who never knows, but they exist. So that's one of them, gallery.azure AI and / the URL to this model. That's here the description of the model, but what you need to do is click here, open in Studio. Open in Studio. That actually will copy this model to your Azure. But before that, you need to create a resource which is called Machine Learning Studio Classic Workspace. Just well, just find it here when you create, and you will get it. So here you click Launch Machine Learning Studio, and you will get to here. So this is Machine Learning Studio is actually a collection of so-called experiments. Experiment is actually the process how to train a model and how to get predictions, and then how to publish that as a web service. In our case, we will get this this picture. So if I will zoom it a little bit, we have here web service input and then web service output. All the magic actually happens here between. Here is our code, and if you will see that for time series story, it uses 3 different mathematical algorithms, which are called ARIMA, ETC, and STL. If you are not like with a mathematical degree, it's okay. If you are interested, you can just Google how this mathematical algorithm works. But on this phase, you should know that well, technically what they are doing, they take your data, so date and amount, and then extrapolate your values to the future. So using these 3 mathematical algorithms. Each algorithm potentially can give different result, and that's why we also have here a combination of these algorithms, like all, or ETC plus ARIMA, or ETC plus STL. So what's a combination? It's actually this model will calculate forecast for using 3 of the algorithms and then calculate the average, so to make the prediction like better. Okay. So now you well, you copied that. You actually don't change here anything, and then you click here like deploy web service. Can I zoom it? No. So deploy web service. What will happen? It will create you a web service here under the web service tab with a key and a URL. Here will be a URL. So you just need to take these 2 parameters and insert here. So to initialize a function. Okay. Now we need to send the historical data about sales to this forecast. It makes actually, if we want to predict forecast only for one item, it will not make sense to send all the data about all items, so we filter here by the item ID. Next step, which is called prepare data. Actually, what is doing inside, he is filling a buffer table. So you can pass there any table, but to send messages to a web service, he uses a special buffer table with a predefined fields. So you specify here what field in your table is a item field. That's from my slide what, answered on what question, and which field in your table is a date field. And so here you specify features. So here you specify 2 features actually, item number, item and date. And then you specify a label, so what you are going to predict. In our case, it will be orders or sales. Then you specify how much data, how much historical data do you want to take from your database to send to the cloud to get a prediction. So you specify here a period type, and here a quantity of this period. So it can be a day, like you can take 1 year, so 365 days, or 1 year and specify here one, whatever. And here you specify a starting forecast date, so from which date you want to get a forecast. Then you execute this get prepared data. Then actually you call the forecast. So with this function call forecast, you specify for how many of the periods you want to get the forecast in the future. In our case, it will be 7, so 7 days. So in this function, actually take your historical data, sends to web service, and return a forecast. And here we actually get the forecast. We just fill another buffer table from the response, and here we show the result, well, to the user, or you can do anything with this result in your cases. Okay. If you noticed, we received some forecast from the web service, but the values for the next 7 days were like the same. If I remember, they were like 60, 67 or whatever. So why the forecast doesn't change? Because a time series API use only 2 features. It's a date and, in our case, item number, which means that there is something else that influence on your predictions that these mathematical models just don't take into account. Okay. So for to add more features, so if you have a situation when 2 features are not enough, there is another API which is called ML Prediction API. So the same story, you have data in Business Central, when, what, how much, but also you have another features which what influence on your sales, like weather, maybe forecast. In our case, it will be some events held by the restaurant. There is a limitation in this framework. It can get only 24 additional features. So, but in many cases it should be enough. You publish a math model in your Azure, the same as a previous demo I showed you. It's actually another model, but the process is the same. There is a new step here, which didn't exist in the time series framework. It's called a training process. What is that? So time series, with a time series forecast, you send it to the cloud, all historical data, every time you wanted to get a forecast, which is, well, increase your productivity, or decrease your productivity, sorry, and influence on the time and whatever. Training process allow you to get forecast without sending all the data every time. You train your model once with the historical data, and then you get this model, and then you can use this model for predictions. I will show you how it works. Yeah, and then you just call this web service using code unit, another code unit 2003, yeah, I guess, send, and then you just send this model and also the features about the future and get predictions. Also, you can, with this framework, you can get some insights about predictions. Late payment prediction extension actually works using this framework. So yeah, here the development process actually and the business process for utilizing this framework splits into two steps. So you train your model, then you make predictions using trained model. Also, you can get with this piece of code, you can get a PDF file from the Azure Machine Learning Service, which will, in a graphical way, will tell you how this model thinks. So this is actually those if-else on the bottom, how the model trained itself using your data. So it take one feature which the model thinks is the most important feature for this forecast. Then if some value it goes to this direction or other direction. This is called actually a tree view, and the depth of these trees can be huge. It could be hundreds, it could be thousands even, different directions. So yeah, you take data, train, model, predict, and research. Let's see the demo, how it works. Just switch to another branch here. So it's train ML model. I'll first publish that and we will see how it works, and then I will describe technical parts of that. So the same data set, actually, yeah, by the way, data set is also a term that you will hear a lot if you are using, if you will dive into machine learning world. So data set, it's actually a table in our case. So I have an action here which is called train. If I will push this action on current phase, actually I will receive an error. That's actually an important error that I want to show to you because it's not very intuitive, but in most cases you will get it, and you should know what to do with that. So the problem here in this column, which is called festival name. So the story here is that there could be some festivals that going on near my place where I sell some food, and they potentially influence on my sales. But in most cases, in most of the days there are no festivals, so the column here is blank, right? And empty values is not something that machine learning process likes, because in machine learning process they will just skip all the records with if there is one in one column there is one empty values. So how to deal with that? Well, very simple. We just will, to train our model, we will just replace blanks to at least to something. We don't care to what, but in this case I will replace just to NA, and that will be a value. So now we can train our model. So what he is doing now, he takes all the data, send it to my web service, then it's actually apply the another mathematical algorithms there, and as a result returns me a model in a base 64 format, which actually it can be like kilobytes of data. So this file in a base 64 format we should save somewhere in a Business Central. Doesn't matter where. We will just save it in a some blob field, and it also gives us the quality of our model. So it tells us, okay, for this model the quality is 50%, so actually for the real cases of course it's very bad. But at least it's in this case it's better than time series API gave us. Also, it returns us this PDF file, which looking at which you can see how this model thinks. I will show that in a minute how you can deal with that. So now model is trained and you are ready to make predictions. So the same way as in a previous demo, we go to the same item. And click here on update forecast. What he's doing now, he's sending, he's not sending all the historical data, he's just sending this trained model to the web service, and also the features about the future to get this forecast. So we see here that, well, the values are actually the same. So what is really the difference between time series? But if we will look how we can look here, it starts with it's something which is called go list, and go list is actually empty in every row. So it goes to no direction, then it checks if there is, if this item in a children menu, and it's actually not, and then it just gives us 140, no, it actually goes, where did it go? Oh, no, it goes, I think here, and then here, so it's 74. So if I will do some adjustments here, I will increase the quantity of this item. So adjust inventory. Just I will say that, okay, I have too much of that. By the way, go list is something that in a restaurant business means that when you go to the restaurant, you will be recommended to purchase some item from the menu from this list. So, and then also I can exclude it from the children menu. Let's see what happens if I will recalculate the forecast once again. So we see that their figures actually changed, and in one day we have 135, in other days we have 108. So why this day is special? That's because of here is some event will happen which actually influence on our forecast. So how it works from the technical point of view? So here we have two code units. So the first one is training. So we utilize here the framework which is called ML prediction management. But also we specify here my model variable in a text format. We will receive the model in this variable later. Also we specify here our custom table, and then we the same way as in previous demo, we connect to the web service. But what is this web service? There is actually another link here, which is called prediction experiment. So the same way you open that in a studio, and that will copy here another experiment, which is called prediction experiment. So the same way you have here web service input, output, and all the magic happens here. So in this framework, the code here is different. Actually, with this framework, what is also important to understand, it can return you not only some integer or decimal values, but also text from the using classificational algorithms. So what does it mean? Assume that, so there are two types of mathematical algorithms that can solve two types of different problems. The first situation, for example, you want to predict some value. In our case, it's sales. It's some decimal or integer. In other case, for example, you want to predict which item will be the most popular during some sales, and which means that you will get a prediction from the fixed list of values. So you have a fixed list of items and you will receive a value from this fixed list. In this case, in the first scenario, regression, so-called regression algorithms will be applied. On the second scenario, classificational algorithms will be applied. That's also important to know. And then, yeah, so you just deploy that as a web service. It will appear here as a separate web service. The same way you get a key and the URL, and paste it here. Then here with a set record, you specify which table you will use for training. It could be any table also. And here, with this code, you actually specify what will be the features. So which columns from your table will influence on your sales. Then you also specify a label. So you specify features, you specify a label. That's something that I showed you before. And then you call this train function. It will actually send all records from your table, train, model, receive, and the output will give us a model in a text format where we will save it in a text variable, and also it will return us a quality of this model. And here you just save this model inside of some setup table. For example, it doesn't matter where, you just need to then pick up this blob when you want to get predictions. And then, yeah, here is a message that your model is trained. Here is the quality. The first step done. Then you need to calculate the forecast. In our case, we call here the same code unit, ML prediction management. Also, we specify the table where we stored our model before, and specify the table from which we trained our model. Also, we specify the buffer table where will be filled with the forecast tables, forecast values by default. So we, the same way, we initialize connection to using the framework. Then we actually set a record here telling which table, the same way as a previous example. Also, we here specify which features will we use for predictions. That actually should be the same features as you used for training. That's important to know. Also, you set the label, what you are going to predict. It should be the same label as you used for training process. And then you predict. So, and in this predict function, you send this model in a text format to the web service. Then you just get the forecast in this buffer table, temp time series forecast, and show that to the user, or you can do anything with that as well. Okay. Going forward. So time series, if we compare time series with ML prediction, we can see that it's better in situations when you have more than two features. It uses a tree regression ANOVA mathematical algorithm. So can we increase the quality of that model? Well, yes. How? We can use more features, for example, or we can build custom ML model. So what is a custom Azure ML API? So you build your model in Azure ML Studio completely from scratch, so you don't take anything existed, you just build that from scratch. You publish that as a web service. You call this web service from Business Central using Code Unit 2001. And actually, here is the link from the previous tech days where I described in detail how to build this model from scratch. But here is, like, once again, how you do that very quickly. So you open Azure Machine Learning Studio. I will show you the demo a bit later. So the first thing, you get your historical data to Machine Learning Studio. Then you, using some import data models. Then you generate new features, prepare data for training. It's actually an optional step. Usually it's required for machine learning process if your initial data set is dirty. If you have good data set, it not required. Then you create actually two data sets from one. That's important step. So you split your data set into training and testing. Then you take the training data set, you train your model, you apply mathematical algorithms that exist in Azure Machine Learning Studio. Then you check the model quality. And if the model quality is suited, you publish that as a web service. Before publishing as a web service, you also do some adjustments to the process. You build the web service input schema. Then you prepare data for predictions. Actually, this step is automatically copied from the previous step. Then you do predictions, applying the already pre-trained model from the previous step. And then you build the web service output schema. So let's see some demo about that as well. So I will switch to another branch here, custom Azure ML. So yeah, here actually we have less code because all magic happens outside. So we will publish that. So here we will go to this plotting that we used before. Click on the update forecast. Now actually what happened, we in Business Central now we don't have anything. We don't have a trained model. We don't have, and we don't send the old historical data to the cloud on this step. In the cloud, we already have a so-called prediction web service, which knows how to create a forecast using the features you send using this ML API. And you see that every day now we have different value. So how does it happen? So if I will return to my experiments, actually this is the process I did to train a model. So I import data from I can import data from Business Central, I can import data from anywhere. I actually do here some data preparations. I will not focus here on the details much. The important things here, two steps. To train your data, you should remove duplicate rows. So what are duplicate rows? It's when you have when you in your data set had information that, for example, this pudding yesterday I sold for $100, and the second row that this pudding yesterday I sold for $200. So where is the truth, right? Which means that this kind of problem is called duplicate rows. You need to somehow solve that. In Machine Learning Studio, there is a model for that, remove duplicate rows. So you can just remove everything or keep only the first one. Then here there's another module that actually you saw in a previous demo where I just replaced blanks to some value. We do the same thing here. So clean missing data, we replace blanks to NA. So here we actually split our data. So I will show you some visualization. Here is my data set which I used to train this model. It consisted of well, at least 40,000 rows and 10 columns. So that's those table that you saw in Business Central actually. Then here I split this dataset into two. So the 80% of the dataset will be used for training, and the rest 20% will be used for testing. So if I will take here the training dataset, it will consist of 30,000 rows. So 10,000 rows will be kept for testing. Here is a module which is called train module. Actually, it has only one configuration parameter. What do you want to predict? Here you specify your label. So in our case, it will be order. And you apply here mathematical algorithms from the list existing here. If you will go to machine learning group, into the initialize model group, you will see actually 4 different groups of mathematical algorithms. The most interesting for us will be classificational algorithms or regression algorithms. So on this phase, you should understand what do you want to predict. If it will be some decimal integer value from unknown list, it will be a regression. If you want to predict something from the fixed list, it will be a classification. It could be some Boolean field, for example, yes or no. In this case, it will be 2 class two-class mathematical algorithms. If you want to take a predictive value from some more bigger list, there is a multi-class algorithms. So that's actually how you decide which algorithms to apply to train your model. So when you're, well, actually to run all these models, here is a action which is called a run. So it's a green now. I will not run that because it will take some time. And then you score the model. What does it mean, score model? You here actually take the testing data set, which is 10,000 rows, and apply trained model that you trained before. And if I will look here, you will see that now I have additional column. So so that's my testing data set. It's 7,500 rows. What's happening here? So to test the quality of the model, it takes the historical data set. And he tries to, well, let's say he tries to predict the past. Okay, so he takes all features from the past. For each row, he make a prediction, and then you can compare what happened in reality and how it would forecast that using your model. So you can, well, check row by row. But here we have also evaluate model model, where you can get the so-called coefficient of determination, which will show you the quality of the model. In this case, it will be 71%, which is, well, even better than we had in using ML prediction API. Then you publish that as a web experiment. As a predictive experiment, the web service. You will get, automatically you will get this picture. So what this picture is about. So actually you receive here web service input. You just need to specify the schema for the web service input without any programming. Just connect it to the module which comes after the data, some data manipulation. So in this case, these columns will be the inputs for our web service. Okay. And then you don't change anything here in the rest. In the end, here is the web service output, which will give you the predictions. Okay. Well, actually, I lighted a little bit. You by default get the connection to here, so by default your web service output will be all your columns from the web service input plus predictions. But you can live with that. I just changed that a little bit so to have more clear web service output. So, and in Business Central, we use another code unit to call this web service, which is called Azure ML Connector. The same way we can we initialize connection using this URI and a key when you publish this your own web service. You specify input name output. By default, it's input 1, output 1. You can take it actually from here. So web service output, it has a name, which is output 1. The same story for web service input. Then you specify your input column names. So they should name in the same way as you have here. as you have here. So that's the name of the columns that are your web service input. Then I'm just looping here from the date to get forecast for the next 7 days. So I call this web service for each day. Actually, there is actually a batch process. It's a little bit more complicated. Just for demo purposes, I leave this call day by day. Then you here specify the values for your columns for the next 7 days. And then you just call this send to Azure ML. So as an output, you will get actually you will get a JSON response where you can just take the orders, the predictions of the orders in a text format. It will come in a text format. Then I just evaluate here to the decimal and save it to my table and then run it here. So that's actually how this works. So if we compare time series, these 3 frameworks, in our case, when I trained a model by myself, I used even more powerful mathematical algorithm, which is called boosted decision tree regression, which just gave me better forecast. And we use here 8 features instead of 6 before. So you still can increase the model quality, maybe adding more features, applying different mathematical algorithms, so or maybe changing parameters in these mathematical algorithms. So yeah, let's return a little bit here. So when important thing that you need to take out from this, that machine learning training process is very creative process. So you're just experimenting, giving more data, maybe another data, adding more columns to data, deleting columns from data, applying more algorithms, testing with different algorithms. And so that's could be time consuming, but you can at least start with these frameworks, which will do all the job for you, and you can just see what happens. Okay, do you want to see something really cool? I have actually prepared 2 cool features. So custom vision. Let's do some custom vision demo. You see my phone? Yeah. So actually here is a Business Central on my, it's a sandbox on my iPhone. I published here one extension that I built for this custom vision demo. So what we're going to do, we will try to purchase this apple. Just making a photo of them from Business Central. So let's try to do that. We'll go to the purchase orders. So we'll create a new purchase order. Come on. For example, it will be some vendor. And I just created a new action here. Create new purchase line from camera. How cool is that? So I just will activate my camera. Let's see if it will work. So I take a picture, I use this. picture, it will actually send this picture to my trained custom vision model. Actually, yeah, that's the second demo that I wanted to show you. Let's do like that. So, first one. Okay. Another side of this apple. Come on. It's about light, I don't know. Let me try here. Yeah, actually, I trained my model to understand if this apple is fresh or not. And if it's spoiled, I just tell that this apple is spoiled and use another one. But it should work like that. Okay, let's go to the custom vision here. So actually, the custom vision, it's I will update it. So a custom vision, it's a tool that allows, yeah, you see that. So that allows you to train your images and to tag them. So actually the images that I took before, so actually I had fresh apples that I trained, and I had spoiled apples that I used to train the spoiled ones. But yeah, and then I trained this model and got the predictions. Now it thinks that, I don't know why, maybe that's because of this light on the background. It thinks that it's spoiled. But we can, actually what we can do right now, let's check. We can actually tag them, and we'll tell that they are fresh. Okay, we'll retrain that. I wasn't expected that I should retrain the model here, but well, we have some time. Come on. It should be quick. Anyway, let's see, while it's training, let's see how it works from Business Central point of view. And then we will try to run this demo once again. So, Custom Vision API. What I'm doing here, actually, I'm creating a new line. I call take picture framework accessible in Business Central. That's my function, abort if spoiled. So that's what's where a custom vision magic happened. And then I save the line if we have fresh apple. So let's go here. So so this is my separate code unit. So how to deal with the custom vision? So we trained model in customvision.ai service, and in Business Central we have image analysis management, and also we have image analysis result. Then we also specify the URI and the key. Let's see if that was trained. Okay, that was somehow trained. Let's okay, publish that, and we can get here a prediction URL. So I will just copy that to here. And then I have also a custom vision key. So it's here. I guess it will be the same. Yeah. And then I just will republish that to my cloud sandbox. Let's see if something changed. So I retrained my model. I republished my okay. That's because I published that. Let's take a purchase order. Let's run this once again. Magic happening or not happening? Yeah. Yeah, we have this item, fresh apple. So let's. We have still 12 minutes. I've prepared something cool for you also. Yeah, let me describe some story also about custom vision. I think 2 minutes will be enough for that. So I just found this story before traveling to directions US this year. So that's a real story about the US Army, how they used custom vision some years ago. So the idea there was that they wanted to train their model to recognize tanks. I was a little bit afraid showing this demo in US. You know, when the Russian guy shows tanks in US, it's maybe somehow. Well, I felt comfortable, but yeah. Yeah, so they trained their model on such kind of pictures. They got a prediction model, and when they tested this model on these pictures, they got 100% accuracy. That they were very happy with that. So actually, they took it then in production. But what happened in production? They took a photo of a tank, but in production it told them that it's not a tank. So, but believe me or not, when they got this picture, it told that it was a tank. So why? Yeah, the sky. Correct. That's because of the sky. They actually, well, custom vision don't know what is train, what is tank, sorry. They trained their model to recognize sky, if there was sky or not. So actually they recognize clouds. That's what can happen with the custom vision. Actually, you should take this in account. Actually, I think that something similar happened here in this demo when lights and maybe background of this table also took into the account. Also, the last thing that I want to show you that was actually the continuation of the first step that you made a selfie and send me. So AI now can produce some art. Did you know about that? Actually, I was in St. Petersburg in Hermitage in May. We had an exhibition which was called AI art, really, and I was very inspired from that. And so there were programmers actually who produced art with artificial intelligence. That's actually something unbelievable happening. So I decided why not to try that during our session. So actually, that's I will run the C# project here. What actually what magic will happen here? So the photos that you sent in email with a flow, I hope they appeared in my Azure container. Yeah, we have these photos. That's your photos actually. I had that some photos before. I think I can just delete them because I didn't know how much of you will send me the photos. So this we will call this API. Well, I used Postman for that. And it will give me actually the URL of some output image. I really don't know what will be the result because it's AI. Come on. So yeah, it's executed successfully. Let's go to. Okay, let's. So actually, what he did, he depending on, well, he took all your photos and generated a face of the, well, I see it's a man. I don't know why it's Asian man. But it consists here, well, if I will, I don't see if I will zoom it, but it really consists of all of your photos, of all of your selfies as tiles. Actually, we can run it once again. It will really generate, I think, another picture from that. Yeah? So, is it magic? Yeah? Cool? I could say that that was the hardest demo for me. I really prepared a lot for that. So, some useful links. Time series API and ML prediction model API, the galleries that I used. Also some links to, I'll start about AI. So now you know how to implement AI. Start and have fun. That's my recommendation. And remember that AI is not a sex and you are not a teenager, so stop talking about it, just do it. Thank you very much for coming, and we have we have 3 T-shirts and 5 minutes for questions if you have them. Yeah? One more beer?
This training the artificial closer.
Yeah.
Okay, can you hear me now? Okay. This training of the artificial intelligence seems a bit awkward for me. So why don't they make the training and testing process just one process? So you just upload one file and then turn a slider how much you want to train and how much you want to test. So it would be a lot easier.
ML framework that I showed, which was the second framework, do the training and testing in one step.
In one, okay.
Yeah. So this quality model that you receive after the ML framework training process, actually on the bottom in this web service, it also splits your data for training and testing, and then do these predictions of the past and give you the quality.
And next part is that if you have to use these remove duplicate lines, so it makes a bit difficult to use, for example, item ledger entries to training. So you have to first pull the data and then compress it and then put it back. So
no, I don't think so. So duplicate lines is actually errors. It's
okay.
It's not related to some business cases. It's something that you have 2 answers on one question. You know.
Yeah.
So in the past, I mean,
for
in
example,
your data.
Yesterday we sold 100 units, and the next line says that we sold 50 units, but that's not an error if it's in the item ledger entry. You just have to calculate them together.
You can, well, yeah, I understand your question. So in item ledger entries, we don't have a grouping by date, right? So we have entries, and one date can have hundreds of entries. It's normal situation because
and that works correctly.
It works, yeah. In this ML Studio, you can also apply grouping if you want to get information, if you want to calculate by dates.
Okay.
You don't need to do anything special in Business Central in this case.
Okay, I think I should have taken part in your workshop.
Thank you. Yeah. Up. You are together or? Okay,
so the question is, if we have our internal ML system apart from Azure, could we theoretically hook up these code units which you have shown us to this system, or is it like really tied to the Azure ML?
I would say that it will be simpler to just call normal HTTP requests. It will be easier for you to deal with another system because, well, in the bottom it's just a web service with a HTTP request and response. These frameworks, they just know how to deal with authentication to Azure ML web services and how to deal with sending these schemas to and from, and also how to store the outputs from that. So it's just like a middle tier that knows how to deal with Azure ML web services. But in other situations, when you have a prediction web services outside or whatever, it doesn't mean where, you can just call normal HTTP request and calls. Maybe it will be just even less lines of code.
Okay, thanks.
My question is, how is the quality calculated actually, based on which criteria?
The quality is calculated using test datasets. So it's, once again, so you, for example, have a dataset how it was in the past. So actually it tries to predict this past. So it takes your datasets, every row he predicts, and then it compares how it was. So that's how you get the model quality.
So it's basically accuracy of the already, okay.
Yeah.
But it can change. For example, if you change the set of data to check, then you will get another quality. So it's not really about the model you built, right, and the algorithm.
That's why you need to have the data set which could have answers on different situations how it was before. Because if something happened in the future that wasn't before, actually he doesn't know how to deal with that. He will give you some estimations, of course, but the difference could be more than expected.
Okay, and the next question is, there are a lot of this mathematical algorithm that you are using, and some of them are not applicable completely in some situations with a specific data set. So how do you know, is there any documentation which algorithm to apply in which cases?
That's a good question. If you will watch the recording from the previous Tech Days, there is in the link. Actually, this will be also recorded and will be on YouTube, so you can just go to the last year. I had a slide there. So which mathematical algorithm should you pick up depending on your problems?
Okay.
Or you can just Google search. It's called, if you will search for Azure ML algorithm cheat sheet, it's called like that. Not shit, but sheet. You will get this picture as well.
Okay, thanks.
I already have t-shirts, so that's
good for you.
Yeah, I have two questions actually. Does it work with on-premise version? This is the first one.
This all you saw here was my local Docker.
Okay.
Well,
great.
except the last demo with image recognition. Well, it's just simpler to connect to cloud from phone.
Cool. And the second one, you showed how we can train the model, feed with data, and get this 5 kilobytes file with base 64 format. But my question, what if I want to keep my model up to date and update it, say, every Sunday night?
You can do that with a ML prediction framework. You can do that. Setting maybe some job queue, and actually I think this kind of job queue already exists in Business Central, just to retrain your model. If you trained your custom model, you should deal with that somehow manually, but also retrain your model and then republish that. Well, actually, that's something that I did during this demo about custom vision model. So I just retrained it, published once again.
Yeah, I just want to automate this process, not to click every.
It's possible.
Every Sunday. Okay.
Well, in custom vision there is an API for that. In in your Azure machine training process, I don't know. Maybe it exists.
Okay, okay, thanks. Спасибо.
Пожалуйста. Any other questions? Oh, okay.
Thank you very much for the demo, first of all. Quick question about, here I am.
Yeah.
So, all of the machine learning, most of the topics are around prediction. I was wondering, is there any more detailed information about other aspects of machine learning and AI in terms of recommendations, decision making, path finding, for instance?
Yeah. If you did you attend the Waldus and Vieco session before?
Don't think so, no.
Yeah, they actually showed how to train custom vision model to give you some recommendations for new items. So if you just liked or disliked some cars, they had that in their demos. So when the store had new car, depending on your previous likes or dislikes, they send you a notification. So that's actually training of a recommendation system. You can, for other services powered by machine learning, you can go to cognitive services. Just, that's a good place where you can just start from.
Okay,
Yeah.
thank you very much.
There is
Спасибо.
a, yeah.
Do you know if Spotify uses AI or
Yeah,
they do?
yeah. Spotify and Netflix.
Yep.
Yeah, that's how they recommend. Oh, Apple as well. Yeah, no. Okay. Thank you.